so much. First of all, happy Friday, everybody. Thanks for coming in to check out this talk. It's a pleasure to be here. It's my second LASCON. I was here in 2019 and quite enjoyed the conference, and I'm glad to be back. I'm going to talk about how you can use the security knowledge framework in ASVS to build more secure applications. This talk was originally created by myself and my colleague Kurt, who unfortunately couldn't be with us due to an illness. So I'm filling in on his behalf, and I'm going to give him tons of credit because he put a lot of effort into putting this together. I can't take all the credit, but we worked on it together. So a little bit about me, Farshad Abasi. I've been in this, I guess, software and security business for over 25 years. I started my software game back in the .com era, built software for about 12 plus years. I would consider myself a full stack engineer before there was a term full stack. I've built web applications, I've written drivers at Intel, I've worked on cellular routing engines at Motorola. I've built all kinds of shapes in software. And after building all the different kinds of software, I kind of thought, hey, I should go and switch to security to help people build secure software. Because guess what? While I was building software, a lot of things that I built got hacked. Not by choice, because variety of reasons that we can talk about later. But I learned a lot of hard lessons, and in fact, I teach a security course in Vancouver at a college called BCIT, and I often have a lot of really good real-life examples. So the comment from everyone's like, "Wow, yeah, you have a lot of good examples from your career." So I hope I can share some of that knowledge with you as well. But for the last 14 years, I've switched on the other side of the fence. So I've been working with software developers and teaching them about my mistakes so that they don't repeat those themselves. I spent a decade as a senior member of HSBC Bank's Global Bank's IT security team. I helped them actually form an application security team back in 2008, where application security was fairly brand new, and the bank, HSBC had a lot of money. They wanted to get into that field. So they assembled a team of software folks that also knew security, and we created a global application security practice. I helped take that practice global, and we built a very successful team that supported about 1,000 different development teams across the bank in different regions to build more secure software. And as you can imagine, in 2008, everything was waterfall. So we went from waterfall to agile in around 2010, 2011, which was fairly new. So we had to figure out how to slide security in there. And then in 2014, 2015, the world went DevOps. So we had to refactor all of our services in terms of software security to fit a DevOps pipeline, which is nowadays you call it DevSecOps, but the term didn't exist at the time. So I've been fortunate enough to be on the forefront of a bunch of these movements, and I have lots of stories and battle scars and lessons to share with you. I'm currently the OWASP Vancouver chapter lead, and we have a board that together we organize a great series of events. We also work with the other chapters in Portland, as well as Seattle and Victoria, and we have a Pacific Northwest conference that we're hoping that it will be as good as LASCON, and some of you can attend as well. I'm also one of the organizers of B-Sides Vancouver and a bunch of other stuff that I'll spare you. And so let's talk about today's topic. First of all, I want to do a quick poll. How many people here are developers or they're building stuff? Okay, few people, that's good. Who's working in security? I'm assuming the rest of you. Okay, cool. So out of those people that are working security, how many of you are working with developers? Okay, cool, awesome. This is the talk for you, because I also work with developers that I'm in security, and this has been a phenomenal tool and that has helped me in my journey working with developers so that they can learn about security in an easy manner. Who's heard of the security knowledge framework? Okay, awesome, cool, bunch of you. And who's heard of ASVS? Awesome, I love ASVS. So currently I run a company called Forward Security. The foundation of our company is based on ASVS. Everything that we do, from our assessments to when we do DevSecOps, and all the work we do is really around ASVS. And myself and team have contributed a whole bunch, and I have Jeff Williams and Jim Manico and all the folks that have contributed to it over the years to thank. And finally, Kubernetes. Let's see, show of hands. Kubernetes, yeah, okay, cool, awesome, that's great. So that's a good background for this talk. So it's Halloween. We've got a stack of pumpkins here, and security knowledge framework is kind of like that. Security knowledge framework, is a bunch of software that a great team has created, plus some data, plus some infrastructure. And the infrastructure is Docker and Kubernetes. So that provides a platform to have containerized applications that demonstrate different vulnerabilities run on it. They're Dockerized containers. The data is primarily around ASVS, and I put a star there because a lot of the data that's populated in Security Knowledge Framework comes from ASVS, but there's other data as well from things like the security testing guide and all other wonderful OWASP projects, as well as external sources of data that they use to enrich ASVS that makes it better for someone who's trying to learn application security. So that basically Security Knowledge Framework takes the ASVS data plus other data and wraps it in a bunch of software and makes it a very easy to use platform that has labs, code examples, knowledge base, and training. And so if your organization is requirements-based focused, the ASVS is really good to use for that. And I know a lot of you are familiar with that already, so I won't go on about that. So what are going to be the takeaways? By the end of this presentation, hopefully you understand how to use ASVS and Security Knowledge Framework together. You'll get some tools for getting it up and running. That was primarily the main motivation for this presentation, because when we tried to get it up and running, we ran into a bunch of challenges. Yes, you can use the web-based version that's there. It's a demo, but if you're trying to run up your own stack, there are incompatibilities with Kubernetes, so we've released some code that I'll share the link with you after so you can take away with you and be able to stand up your own environment, either in a VM on your own machine or in AWS. And that's the primary motivation for this talk. And you also, another takeaway is getting the most out of ASVS and SKF to build more secure applications, and I'll show you how you could do that. And the audience is security practitioners, which a lot of you are, so that it's those who are responsible for building application security programs or helping train developers. And of course, software developers themselves who need to write secure software, right? So I encourage software developers to stand this up and go learn about these security requirements, and so should you. Those of you who are security folks that are working with developers, you should definitely encourage them to use this platform. And of course, any IT or DevOps folks who are just interested in Kubernetes and deploying Security Knowledge Framework, because if you're working at an organization and you want to stand this up, oftentimes it'd be those folks that'd be responsible for doing so. So let's talk about why and how to use Security Knowledge Framework. So, you got ASVS, and it's the basis for testing applications. It's a bunch of requirements, right? I mean, it's the application security verification standard. So there are about 283 or 286 different verification items or requirements that was originally designed for people that are testing, right? So it says ensure or verify that XYZ and ensure so on and so forth. But developers can also leverage those requirements to build against them, kind of like test-driven design, right? In test-driven design, you come up with your test cases and then you design according to that. And it's a similar idea. ASVS, these are the verification or the test cases that a pen tester or a security professional could use to assess the security of an application, but also developers could use it as a requirements to build more secure applications. And it's funny because I often hear from clients that don't really understand application security, hey, I want a coding standard. And everyone says, yeah, use OWASP Top 10 or ASVS as a coding standard. And it's not necessarily directly for coding, but I would say it's more a standard for building secure software. Some of it will involve coding, some of it will involve design and architecture, some of it is process oriented, and we're going to look at that as well. But the three core uses for ASVS are using it as a metric for your application security. And what I mean by that is that it gives the developers and application owners with a yardstick that they can use to assess the degree of trust that can be placed on an application, right? So, for example, if you're an application owner, you say, this system has a lot of sensitive data and is handling, say, medical information or large value transactions. Therefore, they set the bar at ASVS level 3, meaning every single control is in scope. And then you can then measure how you align with that level 3 that you've set as an application owner. Or conversely, you can say my application doesn't include a lot of sensitive data and it includes just some basic data, maybe not a lot of PII, and it's going to be a level 1. So then your yardstick becomes the level 1 set of requirements that are about 130 or so of them. The other thing is you can use it as a guidance for secure development, right? So not a secure coding list, but as a guide that developers can, again, leverage and understand what security should they be building, what technical controls should they be building into their application. And finally, my favorite, using during procurement for application security, right? There's a lot of vendors out there that say, yeah, I pen test your application, and then you get a quote from them and they say, yeah, we're going to test authentication, authorization, some other stuff, right? But then if you ask them, well, what are the test cases? They don't really have them. They just get a professional, they throw them at the application and they just freeform it, right? And then the problem with that is two different people testing the application will come up with different results because they may not be testing exactly the same thing. If ASVS is used as a basis, either for a vulnerability assessment or a pen test, right? If it's used as a basis, then you'll get consistent results. And you don't have to limit yourself to ASVS, right? You can definitely start with ASVS, and if the pen tester wants to freeform it and do more than that, they should be definitely welcome to do so. But at the minimum, there should be that consistency. So I would expect any pen test provider, and I hate to use the term pen testing because OWASP themselves say pen testing is not as effective when you're testing your application. You should be doing a design review and threat modeling and code review and pen testing all together when you're testing your application. But it's still it's a good idea to align all of those activities with ASVS where possible. So again, a lot of you see in ASVS, but just as a refresher, there are these 14 categories. Category 1 is special because it's really around architecture, design, and threat modeling. Is not it's more of a high-level stuff, and it gets a little bit into process as well. Like do you do X, Y, Z, and things like that. The categories 2 towards 14. They pretty much focus on technical controls, right? Things like authentication, session management, access control, all the way to API and web services and configuration. There is a mobile version of ASVS as well, right? There's a web version and a mobile one. The web one was the original one that, of course, it covers web application specific controls, things related to how cookies are handled or content security policies and things like that. It also has a section on API. The mobile one, of course, it focuses on the mobile client specific controls, but it also dabbles a little bit into API. When we use it, I don't usually use the API section from the mobile one. The API section in the web one is more comprehensive, so I tend to rely on that. So if someone comes to me and says, hey, I want to test my mobile app and it has a back end, what I'll do is I'll use the controls for the mobile client from ASVS Mobile, and I'll use the back end controls from this particular standard, so create an aggregate. That's probably the best way to do it. And for those of you who have never seen ASVS, each category is further broken into subcategories. So for example, 7 was error handling and logging, but 7 is further broken into 7.1, 7.2. So as an example here, you can see in section 7.1 is specific to log content. And then they've got the 3 different levels here. You can see that controls 7.11 and 7.12, they apply to all 3, level 1, 2, and 3. So if you say my application is at any ASVS level, these 2 controls would apply. But control 7.1.3 only applies to applications that are determined to be at level 2 or 3 assurance requirement. And so it's nicely organized, and they're actually going through an update right now. Version 5 is supposed to come out, and when I spoke to Jim Manico, he was saying it's going to be the changes are going to be major. So look out for it. I'm pretty excited about the version coming out. We've been contributing quite a bit to the existing version, so hopefully we'll see the results of that. So let's talk about the security knowledge framework itself. So SKF, and I'm going to show it to you in a second, we'll do a quick walkthrough. It has the following key features. It lets you have projects, and I put a couple of stars there because the projects and the learning journey, they're still under heavy development. And in fact, I don't really recommend using the projects. If you're using something like Jira or some other project management tool, you should just manage all your requirements in there. My recommendation would be that you take the ASVS requirements that apply to you, and then you put them in Jira and you track them there, because that's where the developers are living, right? You don't want to introduce yet another system where they're managing requirements. That just people are not going to like that. And one of the main things they say in DevSecOps is don't introduce more tools or things that take the process outside of the developer's existing process or pipeline. So the project one is there. Yeah, question.
So when you say put them in Jira, do you put all 268 or do you put 14 and then categorize them? How do you do that?
Yeah, really good question. So the first thing you should do is you should look at the application and scope out which controls are applicable to you. So what I usually do is so first thing I do is I talk to the dev team or the owner of the project, and let's see what kind of sensitive data this thing handles, right? So then they say, okay, well, it has a lot of PII, but we're not doing like large value payment processing. I'm like, okay, you're probably a level 2, right? Level 2 all narrows it down to about 260, I think. Then out of the 260, we say, okay, not all of those are going to apply to your application. So what you got to do is go through them, and unfortunately go through them one by one. And this takes about 3, when I've done it with clients, it takes about 3 to 5 hours. I usually do 3 different meetings, 1 hour each, and we go through them. I usually give the list to the team. I say, hey, go and read this list and then kind of tick off which ones you think apply to you. And then let's have those 3 meetings, hour each, and then we go through it together, because some of the descriptions are a little bit ambiguous. Even myself, when I'm a security professional, when I first got into ASVS 4 years ago, a lot of it didn't make sense to me. So I help them understand what they actually mean. So then once we've done that exercise, we've scoped it out. It usually narrows it down to a much smaller subset. Then the other thing that we do, and I'm glad you asked this question, so let's say we've narrowed it down to 200. 180, right? Not all of those will be things you put in Jira. So some of those controls, like let's say, for example, there's a whole bunch of them that are related to injecting certain things in the header, in the HTTP response header, right? You can actually create a library out of those, and then the developers can just use that library, and then automatically, every application that's using that library, those headers would get injected, kind of like a cross-cutting concerns, right? That's one subset. The other, there's a bunch of them that they're also cross-cutting concerns, but you can't apply them as a library. As an example, input validation, right? Every field you add to your application will require input validation. So it's not necessarily specific to a particular user story. It just applies everywhere, access control. So what I do with those cross-cutting concerns or those common controls that apply to every user story, I take those and I make a list of them. Of course, these are the ones that the team has determined that are applicable to the application they're building. And then I usually make that list, because you need to have that list somewhere as a reminder, right? So every time they're building a new user story, they think of those common controls. So the best place to do that is not a piece of paper in their cubicle, because no one works in an office anymore. But the best place to do it is a template in the pull request, because a lot of teams are using GitHub or a similar platform, and they're often required to do a pull request, and if someone has to review that and add comments. For example, in GitHub, what you can do is make those controls a template in the pull request. So when the person goes to review them, those 8 or 10 items appear at the top of the page where they provide their review. So it's top of mind. And you can say, have you considered the following 10 controls? So every time they do pull requests, those 10 controls show up. And then it serves as a reminder for them to make sure they've considered them. So that's the second thing. And then the remainder of those, let's say there's like the other 100 that are remaining, there's specific things you have to build. Like, for example, make sure you're using bcrypt with 13 iterations when you hash passwords. That's very specific. So that becomes a user story in Jira. So I throw those as backlog items in Jira, those 100 or so that are remaining, and then we flesh them out. So then we create user stories around them that get implemented. And the thing that you should be doing as well is that you should make sure that the developers are chipping away at it, right? Because it's one thing to throw those 100 controls in the backlog, and it's another, because every sprint they prioritize functional requirements. So ideally, they would grab 1 or 2 of those items in your security epic or security backlog and adding them to each sprint. It's okay for them to maybe have a sprint without any security, but don't let it go for 2 or 3 sprints where they've added nothing from the security backlog. And in my experience, that the typical team that we've worked with that starts at 0, to get them to implement all the level 1 requirements, it takes about a year. Like, just on average, a lot of teams that I've worked with, some teams go faster, some teams go slower, but that's been my experience, is that they chip away at it over a few sprints. It takes about a year for them to implement those things over time. Yes, please.
So with dev teams trying to deploy to production at a fast rate, and
yes,
they have deadlines to meet, how would you recommend enforcing this? And how would you recommend motivating developers?
Good question. So number one, you don't want security to be a hindrance on the agility of DevOps. Absolutely not, right? Like, you want to, what was that famous saying, is like, if a gate takes longer than 9 minutes, you're not agile, right? So you got to make sure everything you're putting in that process doesn't slow things down, right? And and the good news is that these aren't gates that you're putting in the process, right? So these are akin to additional user stories that the business team would provide to you, right? So if the business wants 9 new requirements, they go into backlog, right? And consider these 100 requirements that go into backlog. So they're not gates in the pipeline. They're more user stories that go into the backlog, and then the development team grabs a couple of them each sprint and implements those. So that shouldn't really slow down the pipeline in terms of deployment. Now, having said that, I did mention that some of those things should be put in as a template in the pull request, right? So like in the original example, we were talking about, say, 230 controls. Maybe 15 of them become a library that you make that the teams can use. There's actually an OWASP project. I was talking to Jeff Williams yesterday. He mentioned there is a project that has done that. So let's say some of those become libraries. Well, then that's great. You just tell the developers, hey, use this library, and it automatically applies these 10 controls. That's awesome. Some of them become a list in your pull request because they're common requirements, like access control. Like every user story has to consider access control. So you put those ones as a checklist, as a reminder. So when they do the pull request, it shows up. Hey, have you considered input validation, this? And then the other ones are just user stories that they have to chip away at and build over time. So none of these are a hindrance in the CI/CD pipeline. Cool. Good question. So let me see if I can just quickly give you a tour. And we'll go into a bit more detail. And okay, so here I've got this the official webpage for the Security Knowledge Framework. And then if you go to the demo, I mean, ideally you would stand up your own, and I'm going to show you how to do that. But if you go to the demo, they've got this online, which is good enough for us to have a quick look at. And you can see that they've made it kind of pretty. So if you're a developer, you know, they've kind of made it easy for you to get a head start. If you're a pen tester, they've got a section for you. If you want to go into training labs, you can do that quickly, or you can go to the checklist. All of these things are also available at the top, right? So you can go to your dashboard, which is this. You can go to the projects, which is where you would actually, you know, it's akin to Jira, right? Like you would pick a bunch of requirements and then track them and all that for a specific application. Again, I don't really recommend using this because most teams already have a project management tool. And then the fun part begins here where you have your checklists. So it's got the web ASVS and the mobile ASVS, right? And it's got all the different categories that I was mentioning. You can see, you know, the architecture, design, authentication, et cetera, et cetera. They're all here. You can add your own items as well if you have additional things or requirements that are not here. And then there's the code examples. And for a lot of these ASVS items, it's got examples in different languages like Java, JavaScript, Python. It may not have it for everything. And if it doesn't, the good news is that it's an open source platform. So you can add to it for where examples may be missing. But it's a great starting point. I've been asked by a lot of clients, they're like, hey, I want to, my team is using you know, PHP and they're using Java. Can you do that specifically? And there's a lot of really great examples. And the beauty is that there's traceability, right? So you can pick an ASVS item and then you can go in from the checklist into the code examples. And there's also a lab that correlates to that, right? So it's all traceable from the labs to the code examples to the checklist themselves. And then there's the knowledge base. And one of the things that I really like about this, as opposed to just using ASVS itself, is that ASVS on its own doesn't give a lot of information. So it just says, you know, verify that XYZ. And then the person's like, well, actually, what does that really mean? Right? So you can go in there and you can read more about it. So let's take a look here, for example, in the authentication requirements. There's a whole bunch of them. Okay, this is so you can see here, for example, for 2.1.1, this is what ASVS says. Verify that a user sets passwords at least 12 characters. Well, this is easy. Let's look at a little bit more challenging one. You know, these are verify that password submitted during, let's actually, you know what? Let's look at session management. Let's go to this one. And then, you know, let's pick at any of these, right? Like verify the application generates a new session token on user authentication. So if you really want to know what that really means, you can click here, and there's a lot more detail here about that, which the regular ASVS does not have. So that's one of the advantages of the Security Knowledge Framework, is this enrichment of extra data that helps you really understand what this control is about. And often it has mitigations as well. And the mitigations are also broken into different phases. So it says, if you're trying to achieve this control, there's some stuff you can do during architecture design. So it's got the different phases. Now, in this case, they're both things that you have to do during architecture design, unfortunately, for this control. But if you look at the other ones, there'll be controls that you do during development or during testing and so on and so forth. And then here, it goes into the labs. So for all of those ASVS items, if you really want to know how it actually works, that's where the fun begins. So you can launch a lab, and then in that lab, it'll demonstrate that particular vulnerability in a nice small package. And we'll look at an example of that further on. So let's go back to our presentation here. So, getting it up and running. Yes, this was the motivator for this presentation. So I'm going to talk about how to get it up and running at AWS, but we also released code on the GitHub link that I'll share with you so that you can run it on minikube on your local machine. But if you're working in a large team, it kind of makes sense to set it up in AWS and have the whole team use one instance, right? For the whole company or for the whole team. But if you wanted people to run it on their own machines, we've also made that possible. So quick poll. You already talked about who's using Kubernetes, and I'm assuming most of you know Docker or have used it. Yeah, awesome. AWS, who's in there? Okay, nice. So this would be pretty useful to you. So yeah, there's the URL. So the code that we've created to make this work is released there. Again, I'll put it back on the slide at the end as well. And there are two different ways to work with it, as I mentioned. One is locally using minikube and Docker Compose. This is more suitable for the developer, one person using it. But if you're in a team environment, and particularly if you're the DevOps guy or the IT ops guy, it's valuable to set it up on AWS using kops and terraform. Kops is sometimes referred as kube control for spinning up clusters. Kops lets you create, destroy, and upgrade clusters, and is supported on AWS. So we're going to cover more of that with GKE support in beta and VMware and vSphere support in alpha. So those aren't quite ready for prime time, but the AWS version is, and it does work, and we're going to show you that. Now, the lessons we learned while we were doing this is, one, that you have to use the SOO branch and SKF 4.1 Docker images. So if you're not doing that, you're it's probably not going to work. And then you got to use kops and terraform at AWS. We use Let's Encrypt for the certificates as part of this. And so when you run our code from GitHub, it'll leverage Let's Encrypt, and I'll show you how that works. We'll do a run through. And then it's got various AWS integrations. I highly encourage you to join the Security Knowledge Framework Slack channel in your journey, because if you run into problems, there's great folks there that can help you with that. And the current version of SKF is maxed out at 1.2114. So that's one of the challenges, is because things have gone beyond that to version 1.25. And that's exactly what we've fixed. We've changed parts of the code to make it work, given that SKF has not been updated to work with the latest Kubernetes. So because like the current SKF was designed for Kubernetes 1.21, and there are changes, particularly around the ingress API. So that when this was made, the networking ingress was in beta, but since then is no longer in beta, and there have been slight changes. There's actually there's only two changes in two different parts, as you can see, that we've made. One of them is here related to this line of code, and then the other one is over here that we fixed, and that was part of that was the changes that we made. There were a few other things that we did as well, but those were the primary issues that we resolved. So those areas, hopefully we get rewritten by the project owners, and then this will get fixed. But for the time being, you can leverage the changes that we've made. So let's just do a quick demo here, and I'll just show you how this works. So when you run our scripts, what it'll do is it'll generate a whole bunch of other scripts, and then and they're all numbered really easily. And architecturally, how this works is it sets up two clusters. What it does, I'm just going to run it on double speed here. It basically, you run this, you source this AWS SKF kops shell script, and then it generates these numbered scripts for you. So the first number is the step. So we've got 0, 1, 0, 0, 2, 0, and so on and so forth. So, but you'll see that when you run that, when you source it, you'll see that those scripts automatically, your shell scripts get generated for you. And because of the numbering system, it's easy to run through them. So you start running through all the ones that start with 0, so 0, 1, 0, 2, et cetera, et cetera. Those will set up the labs cluster, because essentially there are two clusters for security, two Kubernetes clusters required for the security knowledge framework. One cluster is going to run all the labs, and the other cluster is going to run what they call demo, or the actual security knowledge framework software itself. Why do we need two clusters? Does anyone want to take a wild guess why they use two clusters for this? And I'll just pause this here so that any idea why they're using two clusters? That was my first question. I was like, hey, how come they didn't just use one Kubernetes cluster and just have the labs be a bunch of containers and then the main application is another container, right? The reason that they wanted to do that is because the labs have vulnerabilities. So if someone breaks out of one of those vulnerabilities, they could technically talk to kube control. And if you're running your command and control there with all your passwords for the users to log in, then they could technically compromise it. It's a bit of an overkill. There are security measures that you can use Kubernetes policies and other namespaces and other things you could segregate and try to make it more secure. But they went on the side of let's be really secure. So for that reason, they set up two clusters. One cluster is used to launch all the labs. The other cluster is used to run the command and control, or the main security knowledge framework application. And that's where it got tricky, right? That's why they need to set up the ingress API on the lab side, so that the command and control can actually call the other side of things and launch the labs. So yeah, as you can see, the scripts run, and then you basically run them in order. And so the first one sets up all the lab piece, and then now we're into the second one, right? Because you can see these ones now start with 1. So 1.1.0, 1.2.0, 1.3.0. So they basically define your demo cluster. You create the demo cluster, they validate it, they create the ingress API, and then they get the ingress API information. The script will automate all of these. It'll set up CNAMEs. As long as you've got your AWS context set up, and the instructions are all provided in the README. So when you go to our GitHub, you'll see all the instructions provided there for you. But if you've configured AWS context with an IAM user that has the right permissions to be able to launch these things, then it should be easy. But if you're running into problems, that's where I encourage you to look. It's probably because you haven't used an IAM user that has the right permissions to be able to launch all these things. So at the end of it, it'll go through. So in this, we've already launched the labs cluster. Now it's going through launching the command and control, of what they call the demo cluster, and then it sets up all the certificates, and at the end it gives you a URL in a second, and then you basically take that URL, and then hopefully you can start using that. So you can see here, Now there's a validator, so it's going to validate. Again, demo is the name they're using for the command and control. So there it is. In this case, that cluster sector SKF /ZX is ready. So then you set up the ingress that you ran the final scripts that we provided there. And in a couple of minutes or less, this is all up and running. So it makes it super easy, and hopefully you won't run into problems. But if you do, grab my email address at the end of this, at the end of the presentation, and give me a shout. And like I said, also join the SKF Slack channel. We often tend to hang out in there, and if we're not there, there's other people that can help you with it as well. And so yeah, and then this is the final step, and you can see these numbers start with the 2. So there's the 200 and 210. And so these last steps that start with the 2, what they're doing, these steps are actually deploying the security knowledge framework software, so you can and the components that are required. The initial steps were all around Kubernetes, and then now you can see we're putting RabbitMQ, MySQL, Flask. These are all the pieces for the actual SKF command and control application. So first you build the labs cluster, then you build the command and control cluster, and then finally you deploy all the moving parts for SKF, and then boom, you've got yourself an environment. And you can see here, it takes a bit for it to come up, so be patient. If you go to your URL and nothing comes up, that just means that things are starting up, so just give it a minute or two. And then ideally it takes a minute or two and it comes up, and then you have a running environment. So I'm just going to stop this here, because then we'll go back and use the live environment to play around with some of the labs that it has. I want to demonstrate an LFI vulnerability as an example here for the audience. So let's go through it here. Oh, did we go back to the beginning? Let's skip here. Something, just give me a second. Okay, we were here. Cool. So we have a use case, right? We have this company, let's take a look, and Acme Corp has 3 developers, they're going to 10 by the end of the year. They want these developers to build secure software. Their dev team knows it's important to be secure, but they have no idea where to begin. And this is pretty common, right? A lot of dev teams are like, hey, I've been told to build a secure application. Where do I get requirements, right? So when I worked at HSBC, while we didn't use this, in fact, I didn't really know about it. A lot of people don't. We ended up creating our own application security standard. It was a lot of work. I don't recommend you doing that. It was myself and 2 other really experienced people. We spent a ton of time. And then when we made it, it kept getting out of date. And ASVS is a open source project. Lots of really smart people contribute to it. So don't make your own application security standard. Just grab this as the application security standard. And that's what the dev teams should do. But they're like, okay, yeah, Farshad, we grabbed ASVS, but we don't understand it. Farshad, you barely understand it yourself. So then the thing is, go here, use SKF, and it's got lots of really detailed explanations. And so what this team wants to do is they want to start building security requirements into their application. So guess what? I'm going to tell them to learn with the security knowledge framework, right? So go and stand this up. As go grab these scripts, set up an environment, and start using it. And let's take a look at an example. Let me actually go to hopefully the internet connection will be solid, and we can. I want to show you the LFI example. So here it is, right? So we've got this. First of all, there's a write-up here. If the person wants to read a bit about it, there's write-ups on all the different labs in here as well, which is really nice. And so you can actually click here. And what it's doing right now is standing up a container demonstrating that vulnerability, right? So here, let's grab that and go and take a look. So this is a mini application that demonstrates this LFI, right? So what is this thing? This is a little sample application. In this sample application, you pick a chapter in a book, like intro, chapter 1, chapter 2, and it'll display the contents of that chapter, right? So, if you pick, here it is, like, etc. So it goes and grabs that. Now, if as a developer, if I go in there and I change, let's take a look at it. Let's do an inspect here. I can't hold a mic. If I go here, you can see that in this drop down, what they're doing. Let's take a look. Yeah. So you can see the select, it has the name and it's got the file name, right? They're actually specifying the file to grab for that. So as a malicious person, I'm like, hey, I'm gonna just play with that and see what I can put in there, right? So what I can put in there is I can change that to file. Maybe I'm interested in the /etc/password file because I know maybe this is a Unix box. So what I'm gonna do, go here, we'll just continue through that. So I'll go and change that file name to something else and see whether it'll grab the file that I want. So let's see here. And so we'll just go, I've just automated this in case something goes wrong because you never know during presentations. Live demos can go wrong. So this is the pre-recorded version of it. So yeah, basically the bad guy or the attacker can go in this case and instead of using that file that was there, you can change that to, etc. passwd. And in this case, when that's done, then now you got the contents of that file. So that just demonstrated that vulnerability really nicely for that person who's trying to learn that. And it focuses on a single vulnerability. There are lots of vulnerable applications, right, that are great. Juice Shop is fantastic. We use Juice Shop to train our developers. There's WebGoat, lots of goats out there. But what they don't do is they don't focus on specific ASVS vulnerabilities, right? They just have like general OWASP top 10 built in. And you're like, well, that's great. We use that for training developers. But if you're trying to have that traceability across from requirements to learning all the way to what's being built, this is way better because now you can say, well, I wanted the developer to build these 100 requirements, and then they can go and learn about those 100 specifically, right? And then also another thing that I usually recommend is focus the training on where the developers are weak. And how do you find out about that? Well, take a look at your last pen test result, or I shouldn't use the word pen test. Take a look at the last application security assessment result, whether it was a code review or threat modeling or pen testing, and then determine where they failed, right? And hopefully you used ASVS to perform that assessment. Let's not call it pen test. Hopefully you used ASVS to do that, and then you're like, yeah, these guys failed on these 100 ASVS items. Then take those and say, hey, developer, you guys failed on these 100. Go and learn about the security knowledge framework, right? So that provides a really nice tie-in from this assessment that you did all the way to the training and the development that you wanted your developers to learn so that they don't repeat those mistakes. So next time, when it's time for the annual assessment, then the developers have learned about them and they built them into the application and they don't repeat the mistakes, right? So I think we're almost nearing the end of time. So takeaway considerations. Use ASVS's security requirements to build and test applications. ASVS is all the things. SKF can help you get more out of ASVS, right? It enriches that, it gives you recommendations, gives you more guidance. Deploy it as part of your application security training program. Harness the power of ASVS and SKF to build a more secure software development lifecycle. And you can customize the code example, so please do it. You can customize the checklist, you can customize the knowledge base, right? Use this as a basis and add a lot more to it to make it fit your environment. And and then as I mentioned, customize the training based on the areas of weakness identified during either testing exercises that you've done yourself or by third parties. And join the SKF effort, right? These are open source projects. They can use your help for sure. So thank you for attending, and I hope you enjoyed this talk. I'd like to open it up for Q&A. Questions. I know there's been some great questions already, but hoping that there's more. If not, that's fine as well. We can always you can always reach out to me directly. My contact information is there. That's my email address. There's our Twitter handle. We're also hiring, so if any of you are interested in a career in application security, working with us to train developers and have some fun on the way. And there's the GitHub URL as well for you to download the code that we talked about. Yes? Can you add your own labs? Yeah, great. We have 100%, and you should. And in fact, that's what we've done. So even Juice Shop, like anything that's containerized, because this is just Kubernetes that launches Docker containers, so you can just add any containerized lab in there. So we took Juice Shop is containerized. We took that and added in here. So now in our team, they can launch Juice Shop from right here. But we did even more. Like we actually looked at the labs they had, and there was a whole bunch missing. So one of our team members went and created 14 new labs that demonstrate very specific things as well. And we just containerized them and we launched them from here. You can do that with other platforms like Hack the Box. There's a whole bunch of other platforms that allow you to do that. But this is great. And then as I mentioned, there's a training module that they're still working on. So right now, without the training module, you can take any containerized lab or application and have it launch from here. But once they finish creating that training module, then you can actually create training paths, right, with scoring and all kinds of really fun stuff. So you can create custom lessons for someone that would involve a select number of labs for a particular learning outcome. So yeah, definitely encourage you to do that. And we'll release the custom labs that we worked on in the next little while as well. We'll probably put them all on our GitHub as well. So if you check out the Forward Security GitHub, we've released a bunch of really good tools. For those of you who are companies are using Graph API, we just released a Burp plugin that lets you automate active scanning for GraphQL. You can cut something that would take 2-3 days of work and doing a lot of manual figuring out where you can insert malicious payloads and all that in GraphQL. APIs, we've automated all that, so it reduces it down to a few minutes. So my colleague Jared worked on that. He did a talk at a couple of B-sides, but yeah, that's all in our Forward Security repository among some other useful tools. Awesome. Other question? Yes, sir.
One more. Do you have any suggestions about prioritizing the trainings for the developers? Let's say that it is we are creating an application from scratch. There's nothing there. We don't have a previous assessment. So, how we could say to a developer, yeah, focus first on this, and then this, and then this.
If you've never done an assessment and you don't know where the weaknesses are, I would suggest you start with level 1. So the ASVS has level 1, 2, and 3. Do make a checklist of just the level 1 items. That's always the best starting point. That's only about 130 controls. It might still be too many, but what you should do is reduce that from 130 based on what we talked about. See what's applicable to you, because not every control is going to apply to every application. So start with level 1 and then further reduce it by doing a sort of a scoping exercise. So go through those 130 controls and ask yourself, does this apply to my application? Because your application may not have a web front end. It might be an API only application, right? And then all of a sudden, a whole bunch of controls are out of scope. Or maybe your application doesn't have certain features. You can take out those controls. So start with level 1 and then scope it out based on your application and reduce it, and then use that as the starting point for your development, for your requirements and for your training.
Yeah, no, I'm saying that after that you're doing that, you will be having, let's say, 60 things that they need to cover.
Right.
But they could not do it in the 60 in the first release. They could be like, okay, 3, or 4, whatever. So which one would be suggested?
So ASVS, okay, there's the right way of doing it and then the quick and dirty way, right? The quick and dirty way is like, I've got a spreadsheet, I've kind of prioritized them, I can send them to you if you're interested. The right way to do it is through threat modeling, right? What you should do is do a threat model on your application, understand what the threat scenario, what are the different threat scenarios that could compromise your application, and then go and pick the ASVS controls that address those threat scenarios, right? So you might end up with 12 threat scenarios, and then each threat scenario is often a chain of different attack steps, right? Attack step 1, 2, 3, 4, and then identify which ASVS controls mitigate each attack step, and then that would be your most, and then ideally the controls that you've selected in that subset, they address all the threat scenarios, but each threat scenario will have a different risk, right? So once you've identified the different threat scenarios, assign risk to them based on impact and likelihood, like how likely is this threat scenario to happen? What is the impact? And then take the high risk ones, and then take the ASVS controls that address the high risk ones, and that should be your first priority.
Okay, thank you.
No problem. Yes?
How much time, person-hours, do you think it would take to maintain this?
To get this up and running. If you use our
Get up and running, but to get up and running and maintain it over time.
maintain, okay, so what do we mean by maintaining? Do you mean like adding items to it and things like that, or?
No, just running it and using it.
Well, like running it, hopefully with the scripts, it's a matter of minutes, right? And then once it's up and running, the developers use it. The maintenance would come in, so for example, if you wanted to make custom labs, or if you want to add additional content, because SKF updates it. So I guess one maintenance would be when they release an update, you'd have to update it as well, right? So that would be a bit of time. And that could be anywhere from 0 to hundreds of hours, like it depends on what they break in their next update, that sort of thing.
Yeah, how much time out of your app 16 time does it take to learn this and then leverage it as well?
Okay, so to SKF itself, once it's up and running, they can use it. The learning part is going to be mostly around understanding those ASVS items. So if that's the main that's the main effort is going. Let's say, for example, in that we were going to do ASVS level 1, and we have 100 items that are in scope. That's where the bulk of the effort comes in when it comes to learning them. So I would say, to implement them, we usually spread it over a year. But if you were to just look at effort to learn all the level 1. Probably about 1 or 2 weeks. I know colleagues that do workshops on this. One of my colleagues goes to companies and does a workshop on to developers to learn how to test and what each of them mean and how to test for them. And that's usually a 1 or 2 week workshop for level 2. So if you were to do it nonstop, hey, just take 2 weeks and do that. But if you spread that 2 weeks over, that really depends on how much effort you want to allocate every sprint. So that'll just spread that 2 weeks of effort into a specific other duration based on your resource availability. Awesome. Cool. Well, then I guess if there are no other questions, we'll wrap it up. I'd like to thank you for attending this. It's been a pleasure to be here. And yeah, don't forget, if you have questions, please email me. There's my email address. And have a wonderful day. Enjoy the rest of the conference.